Welcome again to the Sustainability Podcast. Today, I'm very pleased to be joined again by Randall McNair, scholar and professor, and he's here to talk to us about digital twins.
Yes.
Welcome, Randall. It's great to see you again.
Thanks,
How are you today?
I am doing great today. I just really love these venues. This is an opportunity to come speak at this today. The ARC Forum has provided connections in the industrial space that I would not have been able to have made on my own by providing the platform, the community, the connections. It's an exciting time to be here.
Well, that's superb. And actually, Randall just alluded to it, but we are recording here at the 25th Annual ARC Forum.
Congratulations on your anniversary.
Actually, I believe it's 29th. I misspoke on that one, but that goes to authenticity.
There you go. That's fine.
So, Randall, you're involved in so many things. Perhaps to give us context, can you tell us a little bit about who is Randall McNair? Where did you come from, and why do you know so much about digital twins?
Well, thank you for asking. Essentially, I came from a oil and gas background. I had worked in that industry for about 30 years, and realized while I was in that industry, I needed to have a bigger toolbox to communicate some of the challenges I was facing. I felt like I was ill-equipped to really address some of what I thought were systemic problems, not just within my company, but across industry silos, across various different. We were having a lot of problems communicating the importance and value of information, and how the information would inform the decisions that were being made for the lifecycle management of very complex, very dangerous operational facilities. And I felt like it was a responsibility to bring those decisions with the best information. And a lot of times, a lot of my career was spent helping transition from project into operations. And I felt like we were creating a lot of the digital platforms, the tools to actually provide valuable insights. But a lot of those tools were not being handed over to operations because they had no knowledge or appreciation for the value of those assets. And they were just taking over a physical asset and maybe some paper documentation to go with it, and not specifying what their true needs were. Now, this was 10, 15 years ago, but at this point, Europe had already gone through this phase of doing this kind of innovation and Industry 4.0 innovations, where they were wanting to get to the point of having dark factories and make things more autonomous and take advantage of the future. That pivot had started around 2010. It didn't really reach a critical mass in the US until 8 to 9 years later, when people were thinking about what tools out there could actually help us accomplish what's being done in this industrial space, and providing the digital twins kept coming up as an emerging potential solution. And I wanted to research that because we really, at that point in late 2019, we couldn't even define what a digital twin was.
But earlier, I think what you're describing for me, let me perhaps rephrase it, is you saw the silos and you wanted to break down the silos.
Fundamentally, it's not just breaking down the silos, because the silos exist potentially for a good reason. Because they may be compartmentalized information for the purposes of proprietary knowledge, or they may be compartmentalized it for continuity purposes of the personnel. This was the culture of that particular region. But the silos were not just within disciplines; they were sometimes within organizations. Like the decisions about what to specify to what the standard specification was for a particular engineering requirement may have varied from one region to the next, meaning that the enterprise couldn't really take advantage of the value of that, what was designed at that particular space, because it was being built in a completely different environment from the other operation, which is similar activities but completely different design criteria, and that disconnect that I was seeing, it felt like it was desperate opportunity for innovation. And I went back to get my doctoral degree in basically business administration, because I needed to convince the decision makers the value of their information. And I was looking for a tool that could help me visualize and create a better decision-informing system for them. And digital twins kept coming back and resurfacing as I started connecting with the various different experts. I saw an emerging technology that was ready to hit that moment. And I think we're reaching that tipping point now. For the last couple of years, we've started to see major companies starting to actually get on board and catch up very quickly, particularly with the advent of some of the new technologies like generative AI, which is providing these multi-agent generative systems that are providing with much better decision perspectives that are far in capacity to what they may have originally envisioned as just a standalone visual version of the physical thing.
So let me ask. I mean, you a few times you referred to tools, and is an all-encompassing tool the solution, or and in particular, I'm thinking that, and as you were speaking, there's a number of complex variables there. Standards is one.
Right. Absolutely.
Interoperability is another. Culture is another. How do you wrap all of those into one unified tool?
Well, absolutely, and there is no such single, like the digital twin is a system of systems, and they could all have various different sources. In my definition of a digital twin, it's this like artifactual like mind or brain center, this ecosystem that all of this data lives in. It could be visual, it could also be operational IO information, it could be scan information, it could be information that may have been part of the design, lots of different data sources, but the maintenance histories, the activities that are being done at these facilities, all of those could help inform better decisions about the life cycle of that asset throughout its life cycle. So if you wanted to get to sustainability and reliability for some of these very complex systems, the only way to get to that is if I'm making decisions, I'm not doing it solely with the access to information that I have at my physical hand, like maybe a piece of paper that maybe said this is the history of this asset. I want to be able to model out everything that's ever been done about this type of asset anywhere and use that to say, are you sure you want to hit the go button on that particular decision? And let the systems kind of look at the past, your current circumstances, and then predict that into the future. And the technology to do that is no longer science fiction, it is real. We have the capacity to take our present circumstances, contextualize them based on our past experiences, and then align them with our future objectives and make sure that our decisions that we're making today support those objectives. Because I may transactionally say, I may get more revenue if I make this decision today. You might increase revenue for a few weeks or months, but in fact you created a potential hazard that the facility may not be able to operate at all, and your revenue goes to zero because it's locked down because you made a decision that didn't account for something that the system was aware of, but you weren't. And I'm trying to bring those decision support systems to the people so they're not creating incidents that get people in harm's way unnecessarily.
Randall, I think the legacy definition and perspective of a digital twin is a 3D representation of a building, a facility, pipes, roads. But what I hear you saying is a much more broad definition. There's the inputs I think I heard of real-time or near real-time IoT data coming in. There is the other IT data that's coming in from the IT system. There is the legacy historical maintenance records. There may be the employee worker input content as well. And something else you layered on, of course, is very, very top of mind today, is then AI.
The predictive modeling.
Looking at all of that. Did I miss some components?
No, actually, you did a really good job of outlining what we call the digital twin maturity map, or digital twin maturity life cycle. Essentially, you start out with maybe you just have the design data. Like at a level one digital twin is just what you built initially, and then you start layering it with at the next level of maturity, you would be connecting it maybe with operational data. So you're plugging it into maybe the asset registers. You're bringing in external information to it. When you get to the point where you're now taking all the operational data and it's actually informing decisions and is being maintained live, you're about like at a level 3 level of maturity. It's starting to evolve into something that you're actually consulting for your decisions. And you're getting into the level 4 digital twin, you got to a predictive model where you're actually putting in, based on what I know about this facility, what's been done elsewhere, I can bring in models and say, let's look at the future before we make a decision about the present. And then ultimately the level 5, the ideal, the nirvana state that very few companies have achieved, would be an autonomous facility that's operating as a dark factory. That's the Industry 4.0 digital twin, where it's truly evolved beyond just being a collection of connected information, providing digital inputs, rather they're visual. Visuals will help the individual humans. We visualize things, but computers can actually operate with geopositional information, so just geolocating the information. So knowing where that is, if that's something that I can use that data, geo analysis of the data, where it is, might actually help me make decisions about, can this thing I want to bring in to do this construction fit in the space that I want to do? So I can make decisions about, do I have enough tonnage available to support this new structure that I'm going to purchase in a brownfield situation. So a lot of those decisions that are now being made are like, we don't know what actually we built, whether we can do this thing. So now in order to be able to make any change to an existing complex facility, I have to go do what we call a laser scan, some kind of reality capture, whether it's video, photogrammetry, or some sort of laser scan, LiDAR, capture what's the current state, but that may only give you a surface level information about what's physically there. What's going to tell you about what's actually happening inside of that box. That's where your IoT data is going to say. This was operated at peak pressure for, say, like 75% capacity. This pump was operating at 75% capacity for 27 days. Well, the maintenance requirements for that was set at assuming that it's only operating at 50% capacity, for this particular time. So you've actually now exceeded that, but your maintenance schedule is assuming a baseline. But now you actually can modify your maintenance schedule to react to your real information. So now I might need to replace that filter before it blocks up and causes a function that shuts down the whole facility. Because I opened up the valve to get more money, to push more product through the line, but now I've accelerated my need for preventative maintenance. But we can't really do preventative maintenance unless we know what it is that we're preventing. We can do a lot of preventative maintenance hypothetically, but if we have real data, I don't have to send crews to shut down a facility, shut down an asset to be able to fix something that doesn't need to be fixed yet because it never really reached the thresholds that the original design may have required. So there's a lot of complexity there in that response. But we know these are complex systems that humans individually don't have the capacity to think about all those things. We want to bring those decision points to the decision maker so that they can see the bigger picture that's available to them. Because after the incident happens, all the artifactual data that could have prevented that from happening is available to generally available to the lawyers that are going to go back and look over and try to figure out why the bad thing happened.
What's fascinating to me is that all of that data is not just internal to the organization.
No.
But as you're speaking, I'm thinking that an obvious one for me would be weather. Might impact operations.
Sure.
As well as, then thinking a little bit more broadly, is frankly all of the inputs that are in the supply chain. Of many steps down the supply chain.
For years, when you were managing a project, you have a very complex project. You had your supply chain was considered to be a predictable aspect. Okay, if I order something in, I've got a long lead time. I'm going to receive that asset then. But then, post-pandemic, we're looking at that through a different lens. We've seen supply chain disruptions just by a little bit of shift of the wind in the Suez Canal shut down, several $100 million worth of product was having to now be diverted around South Africa in order to be able to get to its European markets or vice versa.
Or it could be tariffs.
Or any political changes. All of these things are knowable outcomes based on past experiences, whatever you say, whatever the current situations that might affect supply chains, whether it's access to stevedores at the dock and people, supply chains, there are not enough truckers to take the product from the dock out, or there's not enough people there to remove that thing. All of these things affect it, and weather that you mentioned. The fact is, I can now model out if I see a storm that's headed to this particular thing, I might know that I cannot, guarantee that, my last mile distribution is actually going to reach its destination in time for that, deliverable date that may be set. I can get that, model it out, and possibly use that in my decision. Maybe say, okay, I can maybe expedite components through alternate means in that process, and then, I can identify that early enough to be able to circumvent those things before they jeopardize my entire project. We shouldn't be putting our entire projects at risk because of a variable that we think is unknowable. Supply chains are very good places for digital twins to exist because a digital twin of supply chain tells you in real time where everything is, how it's moving, how it's interacting as a system, as opposed, it's not cause and effect anymore. We used to say, you order it here, you're going to get it here. That's cause and effect. But now we're looking at multiple variables, a political upheaval in one community between point A and point C, that just right now there's a blockage due to a choke point in between maybe there's a government that doesn't really like the free flow of stuff going through the Panama Canal, for example. Say someone were to say, well, we're basically going to shut that down. All of a sudden now that's going to affect the supply chains, regardless of whether or not you planned for that or not. You're going to deal with the consequences of it. And these tools give you the ability to model that out a little bit if we give them those inputs and factor them into our decision process. Are you sure you've factored that into your risk plan? Have you guaranteed an insurance? Have you put in an insurance policy in place to not jeopardize the success of this long-term project that you holding the future of your company's at hand? Don't put all of your eggs in a basket that's based on hopes. We got to have use real data. The data's available. Make good decisions.
Randall, that's a fascinating and very in-depth explanation. So thank you very much for that.
Ramble, but
No, it's fine. I really appreciate the granularity there. I know you do an awful lot of speaking and writing and communicating about this topic. Can you share how people can learn a little bit more about your initiatives in this domain?
Well, for the past 2 years or so, I've been spending a lot of my energy learning how to be a university adjunct professor. Essentially, I feel like my 30 years of practical experience in the business world gave me insights that are not doing me any good. They can't do my company any good. I'm gone. I no longer have access to those resources to support them. But there are lessons that I've experienced that I don't want to be. I want them to become lessons learned, not just lessons experienced. The experience that I saw was wasted on me. And if I can share those experiences with the next generation of future innovators and designers and engineers and developers, I might be able to give them a better chance of making demanding the decision support systems be in place. If I can't fix it for this generation, maybe the next one's got a chance to deal with all the problems that we are passing on to them. Maybe we can be a part of the solution. Mm-hmm. So I look at education as a key, partnerships with academia, between business, and it shouldn't just be academia's only customer is the research journals the articles are published in. I think that is a ripe for disruption formula, because if you're writing it, doing your research and writing it, it takes 2 years to publish it. By the time it's published, it's obsolete, and it's like no longer really. It's so impossible to really ingest into the operational context that it's way over the heads. It's written with a lot of statistical numbers and algorithms and things like that, and it might make sense to a researcher who wants to cite your paper, but not necessarily someone who actually has to action that information and turn it into something. So I've started an initiative with the university that I got my doctorate. University of South Florida has this Doctors of Administration program that sponsors an Academia Meets Practice, the AMP conference, which we meet every year, where we bring the academic research that's current and relevant. We feel like it has a story to tell to the local industries, but also from all over. We invite people to come to this one-day event where they get to see firsthand, hear from the academics, the challenges that are being researched and applied and have a practical implication to the businesses. We also show partnerships between those businesses where they're saying, here's use cases. We're going to actually let the practice meet academia and help create that ecosystem where we can actually connect and say, maybe I want to sponsor your research. I want to have people working on these problems so that I can hire later on because they've already solved those problems, and I want to be able to take that solution set, put it into my company on the ground. That's creating a positive feedback loop as opposed to just creating a situation where it's a one and done. I solved this problem, good, I'm done, and that knowledge is lost on that one instance. I can actually generalize it and apply it in multiple contexts by sharing it more universally.
That's tremendous. So you said it was the University of South Florida?
That was where I got my doctorate. The Muma College of Business has an annual conference. It's called the Academia Meets Practice Conference. This year it's going to meet in May. It's available through I'm sorry, I don't have the website. I can give you a link to it.
Sure.
But essentially, what we do is we also have another one that meets later in the year. I think later in June. It's an online, so anyone in the world can dial in and hear about the latest research that practitioner scholars like myself are doing. These are people who have been in business, some of them 30 years, whatever, executives. Mm-hmm. They're now doing practical research for their dissertations because they had the same thing. They have a problem in business, and they needed a bigger toolbox to be able to address that. To
Wow,
communicate
that's
challenge.
fascinating. Certainly, for in the show notes of this podcast episode, we'll put the link and the dates.
And it's a great conference.
For those of you that are listening, it's in Tampa, Florida, in the month of.
It's in the month of May. I believe it's the 15th. I don't have the exact date right now memorized, but I do know that. We've got a great lineup of people who will be attending it and presenting at it, and we've got I think 27 different tracks that are running. So there's a lot of really
amazing.
great information to do, and it's a way to make. I think it's the beginning of a much bigger opportunity.
That's
I think
great.
And it's not
work.
just USF. We have University of Central Florida. We've had other universities participate and bring their research to it. It's been partnerships and collaborations across that. It's just that USF just sees it's being hosted at USF. But it's not just a USF show. It's essentially the idea is that this is the beginning of an ecosystem of how academia is going to connect with practice for everybody. I think this is the beginning of a beautiful future for that.
Wow. Well, Randall, it's been thrilling to have you back here after 2 years in your first visit.
Yeah.
Is there anything? We've got a few minutes left. Is there anything else you'd like to communicate to our audience?
Well, I do want to say thank you very much, Jim, for putting on these kind of podcasts. It's really informative to have the ability to connect with thought leaders, innovators, industry professionals that are dealing with these challenges, and you prompt the right questions. Thank you for your questions and the time that you took to come up with them. But the point is, if we don't have these platforms and we're not talking to one another, we're suffering alone. And I think these kinds of opportunities, whether they be through podcasts or through events like the industry forum, or there's several of these events that happen around the world that are happening. I challenge your audience to get out there, find out who people are talking about. Get on platforms like LinkedIn, communicate, connect with people find out where they're going, where they're speaking, connect with them, engage with them, and get out of your comfort zone and look at the informing possibilities that are out there.
And I'll put out two challenges. One to Randall McNair himself. I know you have a large ecosystem and a large footprint in this domain. I would ask you to send, if there are guests that have compelling application stories in this domain, please send them over, because we would love to promote this same message. And that same call to action goes to our audience. If you do have compelling digital twin stories, Jim Frazier, please contact me, and we'll get you to be a guest here on the podcast as well. My guest again today has been Randall McNair. Randall, thank you very much again for joining us, for all that great information. And we'll see you again on the next episode of the Sustainability Podcast.
Very good. Thank you very much.
You're welcome.